Welcome everybody to week 10, day 3. I've updated the Zybooks and deleted all of the programming out of it. I'll just give you guys till Monday to do the bridges, mountains. Finally, no more extensions on that. So I was working with a lot of students in the office hours right now. So you guys got till Monday to do the bridges, mountains code. Spent all that. We got a lot of stuff to talk about today, so let's get going. And you'll be writing some classes for the first time, but let me do a little bit of lecture first. You'll be surprised by a loud noise. Okay, so if we have a class, and let's have a class called vector2 or something like that. Holds a point in space. Let's just call it a point. Let's call it a point. Okay. It represents a point in a 2D Cartesian coordinate system. Okay. You guys like how I can type without even looking at the screen? My 7th grade computer professor would be proud. Okay. Typed Cartesian enough times in my life. So, how could we use this? Can you guys type into chat, how can I make a point that represents x is equal to 5, y is equal to 10? Make me a point where x is 5 and y is 10. 4th grade typing class is brutal. Yeah, like, it's no joke. Do you guys do like Mavis Beacon teaches typing or anything like that? So make a point where x is 5 and y is 10. Happy when you typed 10 words per minute. Yeah. You guys want to do type racer? Instant death mode. All right, go on Discord. I'm waiting for you guys. Make a variable of type point, named whatever you want to name it. Where no, you got to make the variable, Seguin. Make a variable of type point, name it whatever you want. It's always the hardest part, coming up with the variable name, and initialize its x to 5 and its y to 10. You failed the quiz? Well, give it a shot. Like, what? So what if you get it wrong? It's just going to reveal that you know, you haven't taken computer science before, which I know. It's fine. Yeah. Okay. So let's go over this again, because all those answers are wrong. So if I want to make a point, it's just a variable, right? So you know how like I can make an integer. Oops. You know, can make an integer x equals 5 or something like that. I can make a point, and the name of my point is p. Like that. Okay? And I can initialize it, but it's got 2 different variables, so I can't just say 5, right? Like that doesn't make any sense. You can't initialize p to be 5, because it's 2 variables. Which one am I talking about, x or y? So there is something called universal initialization syntax where I can do this, and that will initialize p.x to 5, p.y to 10. Kind of cool. Another way I could have done it is done point p like that and said p.x equals 5 and p.y equals 10. That's fine too. It's a little more verbose, but you can do it that way. So what else? How else could we do it? We could do it like this. Curly braces, right? Like that. And that would initialize p.x to 5 and p.y to 10. A lot of different ways. We could do a constructor. So we could do a constructor here, point that takes in an int new x and int new y. and we set x equal to new x and y equal to new y. And then this would work if we wanted. This is calling the constructor, the two-parameter constructor. We can't make a point without a constructor because the only constructor, or we can't make a point without a value because the only constructor we have is a two-parameter one. So once you make a constructor, then it sort of requires that a constructor get used. If you don't have any constructor at all, then you can use the UBI, universal, or UIS, whatever it's called. Show you guys something cool. Default parameters. This is something I probably should have mentioned when we were doing functions and didn't. Let's say you want to have a function called like die. This may be familiar to some of you. Okay. You guys remember the die function from our homework assignments? Bridges is extended till Monday. Yeah, looking at the office hours, there's a lot of students that are getting close to finishing, and I don't want you to just give up on it, so I want you to keep working on it. What I care about in this class is students learning. I don't really care about flunking students. You know, I'm not here to filter out the unworthy. I actually want you all to learn the material and get it working. It's crazy, I know. So how can I call die? Die takes a parameter. Die takes a string, right? If I were to pass in die, like this, that'll compile, prints and quits. But if I don't pass in anything at all, it will use the default value instead. Aha. So this is called a default parameter in a function, and a lot of people hate them, by the way. They think it's bad coding or something. But there are times when I think it makes sense. So if you just call die and you don't pass in anything, then it'll print bad input and quit. But sometimes, like maybe you want to give a little more information than just bad input, and you'd be like, your triangle was a square. I don't know. You know what I mean? Like, and so if you pass in a string, then it uses the string you pass in. And if you don't pass in anything, then it prints out the default, bad input. Kind of cool, right? Was that an AOE reference? You know it was. Does that make sense? So if you pass in a parameter, it uses the parameter. If you don't pass in anything, then it uses the default value of bad input. Okay. What's really funny is that people still refer to the priests in Age of Empires 2 as Wololo, but that audio is only from Age of Empires 1. Where if you're trying to convert an enemy troop, you have these priests shaking the stick going wololo, lololo, wololo, lololo, and then it converts the enemy. That's not in Age of Empires 2, but everyone still uses that as the term. Okay. You guys with me on this? Okay. So what I did here is I gave default parameters for the constructor. So I can now create a point P. And if I were to see out P.x and P.y, well, let me ask you, what do you think that this will output? It's not going to be undefined. Oh, ooh, these should not be ints. There should be doubles. That's what happens. My fingers just type int by themselves. Has nothing to do with me. All right. What is happening here? when I make point P, it's going to call a constructor, and it's passing in no values. So what values are x and y going to default to? 0. Yeah, good. So this will print out 0, 0. Now if I make another point, and call this one P2, and for this one I pass in 5. What is this going to print out? Is the 5 going to be x, do you think? Or is it going to be y? Which one do you think it's going to be? Let's compile it and find out. Yeah, it's going to be x. When you pass parameters to a function, they go in left to right. And so for any values you don't pass in, then you get the default. There's no way of defaulting x and not defaulting y. So the order that you make your, if you're doing default values for functions, then you typically put the most important stuff first, and then anything that's like kind of optional, you put last, and you can default that. A little bit of a philosophy design thing. All right, and then if we do this, do P3 and 510. What's that going to print? You got it. So I like making constructors this way, so that if I don't pass in any parameters, then I get some default values. If I pass in 1, then I get 1, 2. Then I only have to make one constructor. Then I don't have to make a default constructor, and a 1-parameter constructor, and a 2-parameter constructor, and a 3-parameter constructor. It gets really tedious copying and pasting it. So I will typically default the values like that. All right, so let's talk about functions. First of all, let's do a little Pythagoras, a little Pythagorean theorem on here. Pi tag. That was his slang name, Pytag. Const point P1, const point P2. So we're going to take in 2 points, and we want to return the distance between P1 and P2. Do you guys remember your algebra? The distance between 2 points in algebra? Directions. That's funny. You guys remember that? It's Pythagorean theorem. Okay. So the distance of the A leg is XA minus XB. The distance of the B leg is the Y's difference. You take those quantities, you square them. You don't need to absolute value them because you're going to square them. You square them, you add them together, and square the result. So this is the that is the equation. Now we could lean on the standard library and just use HiPot, or we could do it ourselves. I think we'll just use HiPot. It's 420 somewhere, right? So return HiPot p1.x minus p2.x, p1.y minus p2.y, like that. Are you in C math or something? Oh, maybe we should call the function, huh? Okay, so distance between P and P1 is pi tag P1. Okay, so You don't like that? Oh, we don't have a P1. P2. I should just call this guy P1. Everything lines up now. P1 and P2. There we go. Okay. P is not declared. Yeah. Okay. So do you guys concur that the distance between 0, 0 and 5, 0 is 5? Yeah? Yeah. Okay. Let's try some different values. I don't know. Let's make you a 3, 4. It's the difference between P1 and P3. So if we've got P1, P1's at 0, 0, right? And so we've got P1 at the origin. We got P3 at 3 to the right, 4 up. Let's see. It's all mirrored. Sorry. There you go. So we got P3 at 3 to the right and 4 up. What is the distance between P1 and P3? Do you guys remember a geometry, a 3, 4, 5 triangle? Stuff like that? Yeah. Pythagorean triple. There's others. So, do that. There you go. So the distance is 5. What about if we made this 1, 1? What is the distance from the origin to 1, 1? 30, 40, 50 triangle. Square root of 2. Good. You didn't know that you were signing up for geometry class today, did you? Okay. So it's 1.414. Yeah. Okay, so it looks like this thing's working pretty well. All right. So do you see how it's nice to just be able to pass a point to a function rather than having to pass in x1, y1, x2, y2? Because then everything just starts getting really kind of like, you know, and then when you do 3D points, you know, then it's like x1, x2, y1, y2, z1, z2, and your brain just goes, you know, when all you really want to do is like, tell me the Pythagorean distance between 2 points. Bloop, bloop. Right? Do you guys see how, like, classes, it just makes everything cleaner, more organized? Like, conceptually, you could just pass in an X and a Y and a Z separately, and you don't need classes. Like, they don't technically do anything, you know, you couldn't do before. But it just organizes your data nicely. Like, because conceptually, a point in 3D space is an X and a Y and a Z, and they go together. They can't ever be found independently of each other, right? Yep. All right, so now we're going to talk about what if we just want to get the distance that something is from the origin. We don't need 2 points for that. Instead, what we could do is make learning point number 1, and maybe this is learning point, maybe this is. Learning point number 1, default values and functions. Useful for C stores. So, yeah, that's the thing. So, learning point number 2. I'm telling you what these things are, by the way, so you can like write them down and study them, because these are the important things. I like to highlight the important things for you to memorize. You can pass classes to functions. And then learning point number 3. You thought a constructor was default values. Yeah, if you have a constructor like this, then it will default to, that is default values. But that's because this is called the default constructor. Not all constructors are default constructors. You can either pass in nothing, like this, which gives you the default values. You can pass in part of the values, which some of them will be initialized, some of them will be defaults. And then you can pass in all the values like this. So this is a very common way of doing it. Just make one constructor rather than making 3. Yep. So that's my pro technique there. You'll see a lot of people make a possible constructor for every possible combination of inputs to it. So if you had an x, a y, and a z, they would have a constructor that just takes the x and the z, and I don't know, it just seems very confusing to me. I just like making one constructor that just handles all the different possibilities. If you don't pass something in, it's 0. Easy. Usually. The only time I wouldn't do 0 by default, can you guys think of a thing in math where you would use 1 as the default instead of 0? Like a mathematical construct, like fractions, yeah, exactly. For fractions, you probably want, your default fraction should probably be 0 over 1, maybe. You know what I mean? Yeah. Yeah, the denominator probably shouldn't be 0 by default. That seems like a really bad idea, just for a number of reasons. So. Yeah, so if I was making a fraction class, I'd probably have the denominator be 1 by default. Also, when you're doing multiplication, multiplication oftentimes works better with 1 because 1's the identity in multiplication and division instead of 0. 0 is the identity for addition and subtraction, right? So there's like probably some philosophical, point to be made there that like the default value should be whatever the identity is. Like if you make a matrix, I don't know if you guys have taken linear algebra yet, but like 1, the identity matrix is, let's show it to you, it's like a diagonal of 1s, looks like this. So that's essentially the number 1 in matrix math. So if you multiply something by that matrix, you get the same value back. So, if I was making a matrix class, I'd probably have it default to this, absent any other reason. You guys understand? So the point here is you don't always have to initialize things to 0. Okay. Other things exist too. Okay. So learning point number 3. Classes can have functions inside them. Vector dot size, s dot at 3. Right? You can add functions to a class. Okay. That's our big topic for today. Please start mulling calculus. Linear algebra is far easier than calculus. The hardest math class I took was differential equations, probably. And then after I finished differential equations, I felt kind of like, I don't know if I'm ready for the next class, because I took 20A, B, C, D, calculus, differentials, integrals, multivariate calculus, differential equations. I skipped E, which is vector calculus, and then I took F, which was linear algebra. And I was not feeling confident going into that class because not only did I not do great in differential equations, I got a B or B plus in it, but like I just constantly felt like my brain was being like ripped apart. I skipped E and then I took F, and I was just ready to just like die. I got an A plus in the class. It was easy. Linear algebra is super easy. It really is. Yeah. It really is. Linear algebra, like, it makes sense. and it's useful. Game programming, like if you want to do game development, you have to learn linear algebra. I teach a real stripped down version of linear algebra in my game development class. Like yesterday, in about an hour, we went over linear algebra, or a good chunk of it at least. So, yeah, super useful stuff. Anyhow, so you can add a function to a class. Let me demonstrate like a very simple thing. Like let's make a function called print, and this will print the to cout. Make it look nice. Add a little parentheses there, and it's going to print out my x, followed by a comma, followed by my y, followed by close parentheses, followed by new line. Did I forget to close quote? I did. Okay. So there we go. We got a print function. And so now, rather than doing this and this and this, I can just say p1 dot print. Do you like how the comments that I put up there appear on Commander of Completion? Kind of cool. This will print the point to cout. Kind of cool. p3.print. Okay. See how it makes the code look a little cleaner, a little nicer. So now, rather than main needing to do p1.x and p2.y and p3.z if we do a 3D one, nope, we just call print. And now it makes our code look a lot cleaner. And we can even pretty print it. And so it's all cleaned up, all pretty nice. And if we ever need to change something, like if I want to add spaces in there or something, like that, all I have to do is change it in one place, and then they're changed everywhere. Whereas before, every time I was printing a point to the screen, I was copying and pasting it, and I have to go and change all of those to match the new format. Now all I have to do is change it in one place. Okay. Linear and differential are similar. I don't know. Maybe your experience is different from mine. Linear algebra, everything just made sense to me. It could have been the professor. I don't know. I feel like my professor is pretty solid for linear algebra. But, yeah. The professor for a differential equation is pretty good too. My integrals professor, kind of hard to understand. The point of the class is the same as the function. What is a class? What is a class? What is the point of the class? A class is a way of organizing data and operations on that data. So it sort of encapsulates both data, in this case an x and a y, and things you can do with that data. For example, printing it to the screen is a very simple one. Or we could do one, and I'll have maybe you guys do it. Void print. Yeah, let's just do this. Double distance. And this should return the distance we are from the origin. And I'll let you guys write this. 5 minutes. Lab time. Begin now. Go. All right, so yeah, this is very similar to what we did down here with the PyTag function, except we don't need to pass in another point to us. We're just going to assume the other point is always 0. So this is just going to be return the hypot Pythagorean theorem of our x and y. That's it. Nope, no P1. No P1. It's us. we just have x, right? If we were passing in another point, then we'd have to say the other point dot x, or the other point dot y. When you're within a class, when you're within a, no, it's good. It's not a mistake. This is a learning point. Is that when you're within a member function for a class, when you're within a member function of a class, you don't need to use dot. You just refer to x and y. Why? Because when you call p1.print, that's going to call this function. It's going to be p1's x and p1's y. Okay. Yeah. Don't turn it into an int, shook. Just leave it as a double. Doesn't pytag take a point and not an int? Yeah, we don't need to call pytag. This is literally just the hypot function. So all you have to do is return hypot my x, my y, and then we can do this and like p1 is p1.distance away from the origin. So yeah, let me fix that printing. I don't like those spaces there. So P1 is 0 away from the origin, P2 is 5 away from the origin, P3 is 1.14 away from the origin. Okay. Yeah, you don't need to subtract 0. Subtracting 0 is an identity kind of thing. Yeah. Okay. So yeah, so if you want to call it, you just call p1.distance. Do you see how nice that is? And so what a class is, philosophically speaking, is it's a bunch of data that lives together, and then you can encode operations that data can do. For example, figure out how far it is away from the origin. Another thing you could do is like we can make this pytag function here a member function as well. We could do something like this: double distance return how far we are from another point. And so this would be sort of, this is an alternative way to write pytag. Okay. And so if we were to do it this way, rather than calling a function, do you guys see what we have here? We've got a global function called pytag that takes 2 points. Pytag takes 2 points. Rather than doing that, we would say p1.distance p3. Do you guys see the code's going to be identical? This code and this code is going to be very, like, I don't want to spoil it for you. I'm going to let you do it. It's going to be basically identical, but if it's a member function, like this is a member function, it's part of the class, then you would say p1.distance because you use dot to pick out things that are part of the class. Whereas this is a global function, and the global function you just refer to as pytag. It's just pytag, and it takes 2 points, like this. And so which one of these is better? I don't know. I don't have an answer for you for that. People will get really chuffed. They'll get really upset. No, my way is best. Which way? I don't know. People will argue until they're blue in the face as to which one of these two approaches is better. I am absolutely going to stay out of that debate, and I will simply say you can do it either way. So I'd like for you to figure out, based on what you know, to write this one over the next 5 minutes. Okay? So I'm going to pause the stream again and just post it on, just wait, give everybody, because when you post an answer on chat, then people will like just be like, oh yeah, that's it. So don't say anything on chat until 5 minutes from now, and then I want you to paste all of your code all at the same time. We can take a look at what people came up with. Okay, begin. All right, everybody, please post their solutions onto Discord. Good job, good job. Yeah, so there's 2 points involved here. One is us, and the other is the point being passed to us. So in this case, us, when you say p1 dot distance, we are p1, right? If we said p3 dot distance, we would be p3. But in this case, p1 dot distance, we're calling distance on p1, so it's going to be p1's x and p1's y when we do this. X. This is p1 dot x, right? So it's literally going to be the same code as this, except it just looks like that instead. Okay. Good. Good. Very good. All right. Yeah. All right. Sweet. So what other things can we do with a point? Well, what about dot product and cross product? What about what other things can we do? Translations? Yeah, we can add 2 points together. 2 points, we can find a slope. Yeah, that's true. Yeah, these are all good things. Let's just do those in order. So we can translate a point. So let's make a void function called translate, taking in another point. Move our x by p2.x and move set our y to be plus equals with p2.y. Oops, what happened here? So I could give you 5 minutes on this, but I'll just write it. X plus equals p2.x, y plus equals p2.y. So what can we do here? So we've got p1, it's at the origin. So you do p1 dot translate. So let's move it. How far do you want to move it? We need to put something in here, right? How far do we want to move the point? Where do you want to move it to? 42. Good answer. So let's move it 42 to the right. And how far up or down? What do you feel like? 5. Okay. So let's do this before printing it. So we'll translate it 42 right and 5 up. Huh? What? Huh? What? How did that happen? How does that work? I mean, I could have made a new variable, right? I could have made a variable called point temp and initialized it to 42.5 and passed in temp here, right? That would be exactly the same thing as what I just did. Do you guys see this? So I'm making a variable called temp. Its x is 42, its y is 5, and I'm passing it in here, and that's going to add 42 to x and 5 to y. But I don't need to go through all that rigmarole. If you're going to make a variable that you're not using again, then just do it like this. Universal initialization syntax. It's pretty cool. Pretty cool stuff. You see that? I am passing in a point to translate, because translate has a parameter right here that takes a point, and point takes a 2-parameter constructor. And so constructors can be used to construct anonymous temporary variables like this that don't ever exist ever again. So this is going to make a brand new point that lives very, very briefly, like a mayfly. It exists just long enough to add 42 to x and 5 to y, and then when we print the answer, we see that P1 is now at 42.5 and is now 42.2966 units away from the origin. It all just clicked. Holy cow. Do you like that, Jensen? I like it. So this allows us to write really cool code. So we got a point, we just say translate it 42 east and 5 north, and it'll move. Kind of cool. What do you guys think? Make sense? Yeah, universal initialization syntax. It's pretty nice. You're not going to see a lot of people using this online because a lot of people are still stuck in the 1980s. Not going to name names, but yeah, universal initialization syntax is part of modern C++. Modern C++ came out in 2011. It's been 10 years. They really should have had time to update their knowledge, but they haven't. So yeah, you'll see people doing more verbose ways of doing the same thing here. All right, so Cromwell wanted to do slope, so let's do that one. So let's have the slope be returned here, double slope, and we don't need to take in any parameter. Oh, actually, because let's take in another parameter. Yeah, const point. And I want you to return the slope of the line from us to P2. Yep. So like if we're 2, and they are 5, the slope is 1. Here. Yeah. 5 minutes. Begin. Wait, magic numbers? Oh, you mean this thing here? Yeah, I mean, I wouldn't write code that way. Like, where did the number 42 come from? But I'm just kind of demoing like how you can. This will move a point. You can move a point right now. So if you're making a physics simulation, like we did last time with the thing bouncing around, we can just have a function on it that will translate it based on the velocity, right? So what we do, Carlos, is when we're running our physics simulation, we'll have one point, for the ball bouncing around, and then every frame will translate it based on the velocity, right? Translation means like moving. Okay, so you have to write this. So you didn't think you were signing up for an algebra class, but you did. So sucks to be you. 5 minutes. Begin. Sorry. Post your solutions. I mute the microphone because I'm listening to Inca music right now. So. Rise over run. Yeah. So there's kind of a possible failure state here, right? And the failure state is when? What happens? Anytime you do division. What is Inca? It's basically Japanese music. It's kind of like the equivalent of blues or like old school country western. The themes of Inca are basically like, you know, you have to leave your lover behind and go back home to be with your parents. You're never going to see them again. Or, you know, and so like one of my favorite songs, the woman has just reached the northernmost tip of Honshu, the main island of Japan. And she's about to get on the ferry to go to Hokkaido. And she says, "Sayonara, anata," you know, goodbye, my dear. You know, I have to go home. You know, other ones are like, you know, a person's been living in Tokyo for 20 years and hasn't seen his family back home in the old rural village where he comes from, and wonders about the girl he used to know and feels homesickness and things like that. So it's yeah, some's better than others, but yeah, there's some pretty good Inca music out there. If x equals p2.x, that's funny. That is funny. That's a cursed map right there. That's funny. Yeah, a certain amount of truth to it. So when is yeah, so the failure state is when it's vertical, right? And technically our code won't crash. It'll return doubles. Have a special value to represent an infinite slope like that. It's called nan, not a number. I don't know if we want to get too far down that path. I think I'll just call die, you know. Alright, so the rise over run. So the rise is the y. Okay. So it's p2.y minus my y, and double run is equal to space in there, p2.x minus my x. Okay. So if run equals 0, or we just write if not run. If run equals 0, then die division by 0 error or something. Okay. So that'll handle that. And then otherwise we just return rise over run. What do you think? Republic of Ireland. It's just called Ireland. It's called that's funny. Honestly, the Republic of Ireland should be where the Republic of Korea was, right? So match the. That's funny. Any questions about this? And then we can compute the slope between 2 points. Let's just not have this guy be quite so far away. Let's see, he's at 5, 0, so let's put this one at 0, 5. Yeah. So. Okay, so that. The slope from P1 to P2 is P1 dot slope P2. So do you guys understand how this is working? So our class has a member function called slope, and slope returns a double, and it takes a parameter of type point. Okay, and we're passing it in by const reference, as we should, because it would be very odd if P2 changed. You know what I mean? It'd be very odd if it changed. It wouldn't, like, you would surprise people. It's not necessarily a good thing. Good, Hester. Good. Okay, so that is how we would call it. And you see how it's just nice and everything's all self-contained. And you just call, you just call the function, and it will give you the slope. Hopefully, let's test it. I haven't tested it yet. Slope from P1 to P2 is -1, because P1 is 5 up, P2 is 5 right, so that is a slope of -1. And if we were to reverse this, we reverse this, then the slope is -1? Still? Oh yeah, that's true. Yeah. Okay. Let's move it to 5, 5. So it's going to be a vertical line now. Division by 0 error, good. Let's move this one to... And the slope is now 1. Because this guy's at 10, 5, so he's 10 to the right, 5 up. This guy is 5 to the right, 0 up, so it's 5 right, 5 up. So it's a slope of 1. Okay. 45 minutes left. Let's do dot product and cross product. That's why not. So dot product is x1, x2 plus y1, y2. Cross product in algebra. I'm giving you the algebra versions here. X1, y2 minus x2, y1. You write both of these. Okay? I'm not going to give you the outline this time. I want you to write both of these algebraic functions. Okay? Take the other point in as a parameter and write both dot product and cross product. You guys ready for this? You guys pumped up? You guys fired? Fired up? I'll put up the my current main.cc is in public now, so if you want to copy, damn it. Why do I keep using tilde? Move public to /public main.cc. Okay, so if you want a copy of this, copy /public main.cc to your current directory. Like that. Okay? That'll give you a good starting point. That'll give you the code that I have, including the description. And I want you to write all of these from scratch, and they will both return a double. Okay? And I'll explain what they do, why you use them. Space. Yeah, I'll explain what they do some other time. Doesn't matter for now. Partial derivatives next. With just 1 point. Technically that's like a partial derivative, right? Like you just, you have 2 points, and you can take the slope in the x direction, the slope in the y direction. Okay. Okay. And on your marks, get set, and code. Damn it. I was just saying the quaternions, it explains itself. You don't even need me to say anything about it. Yeah, so let's do dot product and cross product. So they're both going to return doubles. Dot product. There's always a question of whether you use like camel case, which would look like this, or dot product like this, or I typically use snake case like that. Const point reference p2, that y2y and case. And then for the dot product, we are going to return my x times p2's x plus, yep, very good, my y times p2's y. I don't need parentheses because of the order of operations. And then for not DotProduct, 3S CrossProduct. Very similar. Let's copy and paste this, I think. So it's going to be x times p2 dot times p2 dot y minus y times p2 dot x. There you go. So there you go. That's the thing. You don't need to put parentheses around the whole thing. Return returns whatever expression follows it. You don't need to parenthesize it. Yeah, looks good. You guys are getting this. You guys are getting this. At least the people that are responding. There may be people at home like, I have no idea what's going on. I don't know what's happening. And if you're one of those people, you need to tell me so that I don't like leave you behind, because train's pulling out of the station. Choo choo. You don't want to be left behind. If you have a question, you need to ask. If you don't know what's happening, you need to figure it out. And if you don't know how to write the code, you need to tell me. So, all right. You're going to rewatch it? That's fine. Isn't cross product a vector quantity? There's scalar cross product and there's vector cross product. This is the scalar cross product. So scalar cross product just returns a number. The vector cross product returns a vector pointing orthogonal to the point, to the 2 points passed in. So this is scalar cross product. You ever got your ticket for the train? Okay. So what we're doing here with our lab time today, we still got half an hour left. If you want to return a vector, you could just return a point, right? So, yeah. But you'd take in probably... It's too complicated to do right now, because you would have to have two different line segments, so two pairs of points. So you need to make a line segment class, which has 2 points. Then you cross product them. It returns another line segment pointing upwards. It's too much for right now. Okay. Dot and cross at the same time. Interesting. Okay. So you made a class called product that has a member called dot and cross in it, but then you made a function called so this is not gonna return ever. It's an infinite loop. You have a function that calls itself, which calls itself, which calls itself, which calls itself, and this class isn't doing anything. You're never making a variable of the type called product. You just and you don't have a type here, and you don't have a type here either. Yeah. So this is how you do it. You have a class called point. It's got some member variables in it, and then you can make a member function on it like this. It's not in global space. This is in global space. This is the end here of point. So this is the end of the point class right here. Okay. So what can you do with dot product? Dot product is useful for determining if two vectors are pointing the same way. So like in a video game, if you stab somebody, you typically draw a trace line. There's a function called trace line that tells you, you shoot like if you have a knife, what you do is you shoot an invisible line through the world, and it will return the first person you hit. Cool. So if you stab, that's the person you're going to hit, and the trace line would probably have a range equal to about 1 meter or so. And you want to know, did that person I hit, is he facing me, or is he facing away from me? If he's facing away, it'll do double damage. And so what you do is you get the direction they're looking, you get the direction you're looking, and you dot product them. And if you get a number that is, you'll get a number from -1 to +1. -1 means they're directly looking at you. 0 means they're at a right angle. 1 means they're looking the same way as you. And if it's like kind of off a little bit, that'll be like 0.7, 0.3, 0, negative 0.3, negative 0.7, negative 1 when they're pointing in opposite directions. And so we'll give you a number that ranges smoothly. It's the cosine of the angles, basically, that it gives you. And so what you can do is you can say if the dot product is greater than 0.6, then we're pretty much looking in the same direction, which means I'm behind them, so double damage. And so that's how you can implement like backstab code and stuff like that. Cross product is useful for telling you is somebody to my left or is somebody to my right. If you get a positive value, they're to the left of you. If you get a negative value, they're to the right of you. And that's also very useful in video games and stuff like that. Okay. Yeah, typically, see-outing is kind of weird. Like, you typically actually don't want to see-out anything in a class. Because, like, if you're sharing your class with somebody else, like, they would get kind of annoyed if, like, your code just suddenly starts, like, talking. You know, like, what the hell? You know, I'm just trying to use your point class, man, and it's talking. I don't want it to talk, you know. So even something like this, I'd probably not do. There's something called exceptions that I would probably throw instead, but yeah, you generally want all of your C-outs to be done like in main, and then your classes, you'll do C-outs like when you're debugging, like you see out all the things when you're debugging your class and making sure it all works. But I would, in general, good class design, you don't see out anything in a class. Okay. Okay, or you can have the backstab damage work based on the, yeah, that's true. Have it do more damage the more to the side, or the more, you know, behind them you are. Sure. Okay. Make a triangle class. How would you describe a triangle? What is a triangle? If you guys took geometry, you'll know there's actually different ways that you could actually write this class. There's a lot of different ways you can describe a triangle. What do you think? How would you do it? Side, angle, side, 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 point, point, point. How would you make a triangle class? 3 sides, and the sum of interior angles is 180 degrees. Yeah, but I mean, do you need just, like, when I'm talking about, like, how would you, what goes here? You know what I mean? How would you make a triangle class? 3 points and 3 sides. You do that, but it's a little redundant, because if you have the points, you have the sides, right? The points are the sides, essentially, right? So what would you put in here? Just 3 points? 3 sides? 3 angles? Side, angle, side? What'd you do? Points? Okay. Thankfully, we already have a point class, don't we? So, point P1, P2, P3. There you go. You got a triangle. Done. It's a very simple triangle. Doesn't do any error checking. Right? Like, what if we made all 3 of the points 0, 0, 0, 0, and 0, 0? Then it's not really very much of a triangle, is it? It's kind of a point. So, but this is a triangle. That's it. If you want the world's easiest to code triangle class, there you go. You can figure out the angles from it using the dot product and cross product. In fact, you can figure out the internal angles. You can draw it to the screen if you want using the colors library. There you go. That's a triangle class. So what can we do with the triangle class? Make triangles. We can render them to the screen. Most video games are just triangles, right? You have a bunch of triangles in a 3D world. Got a camera. The camera's looking at the triangles. It draws all the triangles. And then that's it. You just do that 60 times a second. You got a video game. Colors of triangles on them. The colors of triangles on them. The colors of triangles on them. The triangles have colors on them. I'm having a stroke right now or something. The triangles have colors on them. More specifically, they have textures on them. So the triangles, at every point on a triangle, there's usually a picture that's being looked up, and then it does lighting calculations. It's complicated, but essentially there is a point of color on every point on a triangle, and it just draws all of those to the screen using some linear algebra. What can we do with the triangle? Write a function that detects collision. Good. Collision on a triangle is... it's not hard, but you kind of have to think about it a little bit. Oh, look at this. I have the... line intersections, line intersection, ambient occlusion, bounding boxes, projection matrices. Where are you? There we go. So, yeah. So triangle intersection can be a little bit annoying. If you want to do intersections, usually bounding boxes are a little bit easier. So why don't we do that for our last 20 minutes of class? Let's not make a triangle class. Let's make a rectangle. And rather than doing a bunch of points, we will just do double min x, max x, min y, max y. Make a constructor, double min y, double max. Why am I starting with y? Min x, double max x, double min y, double max y. Shortcut notation. And I'm not going to go into that yet. Just say this points to min x equals min x yy 3p. Good. And so some people code this way. At Fresno State, this is a very common coding style where the constructor parameters have the exact same name as the member variable parameters. I prefer doing it this way, where I call it new x versus x and new y versus y. But at like Fresno State, they typically do it this way. And then the min x is going to shadow the member variable. So you have to specify my min x is equal to min x. My max x equals max x. It's a different coding style. So what I'd like for you to do, very simple, the last 20 minutes of class. Bool is in. It's going to take a point. And I'll put this up on main so you don't have to, it's called P. And I want you to return true if P is inside the rectangle. Okay. So again, copy from public main.cc to your current directory, like that. And we are going to do point rectangle intersection. Okay, so given a rectangle, you might have to sketch this out on a piece of paper. Given a rectangle, is this point within the rectangle? Return true or false. Okay. And actually, let me set these some default parameters here. Actually, no, let's not. Let's just leave it like that. Okay. And so if you want to test it down in main, you're going to have to make a rectangle and make a point and see if the point's in the rectangle. 0, 0 to 5, 5 square. See if the point 3, 3 is in between. You guys understand? Can you do it? At 20 minutes. Inside and on the border? Sure. I mean, normally if you draw a point on the line, you would normally say that's an intersect. It doesn't have to be. It's a double, so exact matches rarely happen anyway. So. All right, begin. All right, welcome back, everyone. I added to main down here a variable of type rectangle, and it's min x, min y, min x, max x, min y, max y. So it goes from 0, 0 to 10, 10. And we want to know if P1, this point here, which is at 10, 5, is inside of the rectangle. And there's a philosophical debate over whether something round on the edge is inside of it or not. I don't really care one way or the other. So there's a couple different observations we can make and a couple different ways we can code it. Basically, a rectangle looks like this, you know? And so if you have a point, you can just kind of check to see if the x is within the bounds of the min x and max x, and the points y is between the bounds of the min y and the max y. So there's like 3 or 4 different ways you can code this easily. Let's do it this way. If P... You can do it all at once, or I could split it up. You know, I'll split it up for you. So if P's x is less than our minimum x, then it is outside of the rectangle, right? So if it's at negative 100, that's lower than our minimum x, 0. So it's not in the rectangle. I normally wouldn't code it this way, but it breaks it up because large if statements can confuse students sometimes. So if the x, so we got a rectangle. If the point is out, if it's lower than our minimum or if it's bigger than our maximum, it's not in the rectangle. And if it's y is bigger than our maximum or lower than our minimum, then it is not in the rectangle. If we pass all of those cases, it is within the rectangle. So this is the opposite of how probably most of you coded it, and I probably would not code it this way in practice, but this way you don't have to have any ands or ors or nots and things like that. Can you just format a single line if with line breaks? Yeah, you can. So like if we want to do this with one line, then we would say if p dot x is greater than or equal to min x and p dot x is less than or equal to max x, return, and p dot y is greater than or equal to min y and p dot y is less than or equal to min max y. That. Return true. Else. Return false. Yeah, you can do that. It's a thing. You can do it. I don't know if I would do that, but you could do it. Yeah, sure. White space doesn't matter. Yeah, or you can do it with just 4 nested and. So You can get around having to have an and by just having an if inside of an if inside of an if inside of an if. That's another way you can do it. This is like ors, you know. So I could have said if p.x is less than min.x, or p.x is greater than max.x, or, and so parallel if statements like this are the same thing as ors. And if you have a nested if statement like this, it's equivalent to doing an and. So either way works. Yeah. Okay. So let's see if it works. So P1 is inside the rectangle. And if we were to move it outside the rectangle, then it is not inside the rectangle. Okay, that's it for today. It's 2 o'clock. Time for the next class to swap in. And I will put this code up into week 10 day 3.cc. Copy main.cc into week 10 day 3.cc. If you guys want to copy that, copy public week 10 day 3.cc to your current directory if you want to copy that. SDs, you left off the dot. You didn't print the dot. You have to type the dot. That's not like me ending a sentence. In Unix, or if you want, you can do a tilde like that. The tilde is your home directory. Dot is your current directory. So if you don't type the dot, then it won't copy anything. All right. See you 12 o'clock people, 2 o'clock people. Come on in.